No shortage of sun in the high desert. You'll see the path it takes to energize this home.
A house built from bales of straw? It's not as crazy as it sounds.
And we're slinging mud for a good cause. Earth-friendly interior walls. That's next on Gimme Shelter. Hello there, everybody. I'm Harvey.
And I'm Robin Kipp, and today we're working in Santa Fe, New Mexico on a house the likes of which we've never seen before, for many reasons, but number one, because it's made with bales of straw.
Now, it's not exactly a new idea out here, but I must say it certainly surprised us. And we'll show you the hows and the whys of this kind of straw bale construction.
From the outside in, we're going to show you this fascinating process, from the mud pits to the great walls and floors.
Now, the homeowners are using materials that they're finding right out here on the site, and they're going to great trouble to try to create an environmentally friendly house. We've got a great show for you today.
Welcome to Gimme Shelter.
This is Birkani from Celestial Constructions and Birkani Architects, which means that, Aram, you're both the architect, designer, and the builder of this house. And you really gravitate to very different kinds of construction projects. This house, for one, I mean, just looking at it, we can see it's made from straw.
Yes.
Tell us about that. Why in the world would you choose to do straw bale?
Straw is a largely wasted product around the world, and it has been burned and creates emissions in the atmosphere. So builders have been trying to articulate it for building systems. That interested me. And plus the insulative factors of it is very high. It's an R48 insulation value.
A bale of straw is R48.
18-inch straw, R48.
Wow, that's amazing, because, I mean, as you well know, standard construction in the United States requires, in most areas, R19 in the walls. And look how much more you're getting out of it.
Yes, it's 2.5 times the insulation rate. The first floor is right now it's concrete, but actually it's a straw bale wall
There's straw
system
behind that, right?
Yes, and this is actually a second story is completely straw also.
Now that's unusual in that it's a two-story house. I mean, I guess some people would look at that and think, well, how sturdy could a bunch of straw be, you know?
Yes, because you see most straw bale buildings, you can see the framing system. Either it's a wood post or beam or a concrete post and beam.
Right.
In our system, because of the cores being located in the middle of the bale, from a distance everybody wonders what holds the building. But the framing is really inside, every 20 inches, a column, 4-inch thick.
We can't see it, but it's there. Making those walls rigid. You're very environmentally conscious with your buildings, and there's another really interesting aspect to this environmental friendly way you build around the front of the house. Let's go take a look out there.
Yeah.
Aram, out front here, this is part of the septic system, but it's very different than an ordinary septic system. Explain this one to me.
Yes, ordinary septic systems takes the effluent after the septic tank and feeds it into a leach field that leaches into subgrade below. And in this system we really don't want that to happen, so that the effluent doesn't mix with the aquifers below.
The effluent being the water that's pouring off the top of a septic tank. Okay.
Yes. And here we fill it with pumice granules, and the pumice granules wicks the effluent into it and then evaporates it to the atmosphere. This creates a humid condition in this desert climate, and we plant fruit trees, ornamental flowers. That's why its location is close to the building, because your front yard becomes totally lush.
Now, you say it's evaporating. Here's another question I guess I just thought of, is do you smell anything?
No, you don't, because it breaks. At the bottom of this leach field we put horse manure, which starts the breakdown process. You don't smell anything.
Not even the horse manure?
No.
And it's being this close to the house, that's really fascinating. Well, I know we want to get back to work, so thanks so much for your time. idea of using straw bales for construction isn't a new idea. It's been around about 100 years or so. American settlers did it initially. And then the revival out here in the Southwest about 10 years ago, they love it for its insulation properties, and they basically stack the straw bales in place. But now the system that we're going to see today is very different from that. And Aram, your company not only came up with a modification, but the equipment to make it happen. Is that right?
Yes.
Tell me about this. This is a great story.
When I came to Southwest, I realized that the straw bales were used in conjunction with a wooden post and beam system. And this was really replicating the structure twice. So we thought of drilling some cores into the straw bales to use them for vertical posts,
right,
as we are staggering the bales on top of each other. So we do three things at the same time. We have the insulation, we have the posts, and we have the formwork to pour the concrete.
Now, this machine that we're standing by is the heart of the system, isn't it? The bale block system.
Yes.
You core out these bales with this. You drill in a big hole in them.
Yes, we can actually change the sizes of these cores. For one-story buildings and two-story buildings, we use 4-inch coring, and for larger, taller buildings, we can go 6 or 8 inches.
Now, how far apart are the holes in the bale?
The holes are 20 inches apart, which means that you're getting columns every 20 inches in the wall.
And as I understand it, when you're stacking the bales, these holes, these cores, they all line up all the way through the wall, so you have one big long poured concrete column, is that right?
Yes, they are poured in stages every 2 bales, but once it is finished, you have a continuous 8 feet or 10 feet columns.
So that really locks the whole wall together and transfers the load back down
to the foundation.
To the foundation.
Yes.
The machine fascinates me. This is great. You came up with this? This is your design?
Yes, after 4 trials, this is
this is version 4?
Version 4, and we're working on version 5.
Wow. This is really cool. Now, this is the cutter?
Yes.
Out here?
These are the cutter heads, and we replace them for each job because straw is a very strong material. Fibers are very hard to cut.
So these sharp teeth will actually get dulled by going through the straw?
Very quickly, yes.
That's interesting. Well, are you ready to do one?
Yes, let's do one.
I want to see it work.
See how it works.
All right. Let's get this bale in place here. Now, these straw bales that you get, these are the same kind that a farmer would buy?
Yes, these actually, the farmers are doing more denser bales for the building industry.
Uh-huh.
And these weigh about 50 pounds per bale.
And we have a generator going behind us. Keep in mind, we're off the grid out here. That's why this is a solar house. So in order to get the power, 220, we've got a generator running. Wow, look at that. But you really got to lean into it just a bit to get them through, but here they are on the other side. And here's all the straw that you've cut out. Now, you do it by hand like this, Aram?
Not all the time. We use a spear to discharge it.
If you're doing a whole lot at one time. And so now, when you pull your machine back out, the bale is ready to go?
Yes, sir.
All right. Well, we're going to take this bale over to the foundation where we're working, and later in the show, we'll get to see this bale block system actually in practice.
This room is going to be the kitchen. It has beautiful views from either side, but the focal point is the dome ceiling. Have you ever wondered how they make a cement dome ceiling? Well, we did too, and we're about to find out just as soon as I get down. This is a great model that you've made here. Can you take me through the steps of how you got here?
Sure. First we draw a circle that's 10 feet in diameter, and we divide it into 30-degree angles, which is about 12 pies. And then we calculate the circumference, half circumference of the 10 feet diameter circle, and we bend our rebars like you see. And we get 6 rebars. When they cross each other, it makes 12 pies. And then we diagonally tie these segments together. Once we have it stiffened up, we add a front entry door, which we turn one rebar here and another rebar right along at the intersection line. And then we get metal plaster lat and we tie it from the inner surface so that it gives us some thickness here to fill with cement. Now then, once this is all done, we get some cement, and you see, the thinner the better. So the first coat is and Arnaldo will start at the top. Once this is dry, we put about 1 or 2 more layers to give it circular shape. And after that, we cover it with styrene.
This is a small model compared to the kitchen ceiling. Is there anything else you have to do for such a big dome ceiling?
For larger domes, we use larger rebars. And after the first coat, it gives a stiffness. And then we do a couple of coats more to get the shapes into trueness. And then we coat it with polystyrene spray-on insulation, which we can see at the back in the kitchen.
We use a polyurethane foam. It expands, and we put on one layer, and then we put on another layer. With each inch, there's about 6.5 R value. We're going to have about 4 inches of this, so it'll be about an R value of 26, which will keep this house nice and warm during the winter months. Once the polyurethane foam is on, it's time for the layers of elastomeric, which is a cement that will expand and contract according to the weather, which is terrific out here in the high desert. The first layer is going to be white, and the second layer is going to be blue. That's the color the homeowner has chosen.
Now, in this part of New Mexico, we're blessed with about 300 days on average a year of sunshine. Now, why is that an important fact? Well, let's go to troubleshooter Tony Buck, and he'll tell us exactly why that's such good news for our homeowners here.
This house is located some distance from the national power grid system, so our homeowners decided to go with solar power. He's going to be using 3 kinds of systems, and one of them is this photovoltaic panel over here, and this captures energy from the sun and turns it into low voltage electricity. That electricity goes down the panel there, down the wires, under the ground to the storage system that's over there. And it's in this small building where we capture the low voltage current coming from the panels outside. And underneath this cover, you can see this great collection of batteries. All that power trickles into here, slowly filling them all up with power, because you need a reservoir of power to run things in the house. You can't just take it from that little trickle from the panels. And this huge, vast amount of power surges across here through all these pipes to the power conversion center. Now, these special boxes here are capable of taking that low voltage power and turning it into 110 volt or 12 volt system, which is then fed through these wires here into the house. And that allows you to run your electric lights, heat water for showers and so on, and run your stereo and things like that, so you can really enjoy your environment.
You know, one of the great things about this house is no matter what direction you look, you've got a spectacular view. I'm sure it's one of the things that attracted our homeowners to this particular site, and it's why they've chosen to build their dream house here. Robin is out in front of the house right now, in fact, talking with our homeowners, so let's go check in with her.
I'm here with Cleo and Saul Hill, and they are the homeowners here. Now, I know you're doing a lot of things to make this house environmentally friendly. Tell me some of the aspects that you're working on.
Well, I guess it starts with the choice of materials. We chose to work with strawbale because of cost and because it's basically a throwaway material that is in some places burned if it's not used for productive purpose. It has fantastic insulation value and it breathes. So we've compromised a little bit with the concrete stucco, but that adds a protection that kind of gave us an ease of mind.
The solar energy.
The solar power. Yeah, we chose to go off-grid entirely. So one thing I like about solar power is, besides being renewable energy source with all of that, it's a nice way to kind of just pay attention to what the weather is up to.
Now, Cleo, did you come up with the design for this house? It's very unique. I haven't seen domes like this in the area.
Actually, he was the one that wanted the domes.
Really?
And I wanted just a house on one level. I did not want to go up any stairs. So I have a disabled son, so I wanted it all to be wheelchair accessible and easy to move around and spacious. And then we came up with the second floor because it was just, the view was so beautiful. So it was an afterthought.
You have a lot of neat shapes here, from domes to pyramids to a box shape. How would you categorize the style of your home?
Well, we wanted a very creative house, and Saul really wanted domes, so he came up with a lot of the design for it.
I had the desire for a circular domed kitchen and a dome over the master bedroom. And a lot of the style is credit to the architect who took, we worked together. I wanted a long, thin house with a public side and a private side, and a distinctive entrance and a greenhouse in the middle, separating the two halves. And the architect took all my ideas and we worked together with the layout, but then he put basically the shapes together by adding the pyramid in there and a barrel vault or two, and of course I just fell in love with it. So.
Well, I know you're doing a lot of the work yourself here, so I better let you get back to work. But thank you very much.
Well, like so many different parts of this house, what we're seeing for a choice for interior finish on the walls is an unconventional choice. What a surprise. This is the kind of house where we're seeing this kind of work, and we're working with Keely Megan from Artisan Earth. And Keely, you're working on the interior finish. You're a natural materials plasterer. Does that describe what you do?
Earth plasterer, yes.
Earth plasterer, okay. We've got a whole bunch of different materials here, and you're working on your mix. And the first one I can't help but notice is this pile of horse poop over here.
Exactly.
What are we doing here?
Well, the horse manure provides a couple of different things. It's an excellent binder and strengthener for the mix. It's got a lot of small fibers in it that you can see. And it also has some enzymes in there that are just kind of magical glue. And
I'll take your word
we love it. Yeah, it's good stuff. We put it through a screen before we put it in the mix. Our basic ingredient for all our plasters is the earth. And soils come in so many different varieties. There is no standard mix for an earth plaster. Some of these have excellent hard binding clays. Some of them have clays that crack a lot. Some of them have the perfect amount of sand in, some of them don't.
Now I'm sorry for interrupting. This may seem obvious, but I mean, this is from right here, this pile of dirt?
Absolutely. Came right out of the foundation.
Off the site.
Yeah.
Okay.
So,
and what are some of the other buckets have in it that you're mixing in with?
Okay, well, we've got the sand, the manure. This is a flour paste that is boiled flour, basically. It's the same thing you use for putting up...
is it like old wallpaper paste?
Old wallpaper paste, exactly.
Okay, yeah, sure.
Just boiled flour and water.
And one of these buckets has some glue in it, you were telling me?
Yes, there's an old casing glue that we use. Elmer's glue you can put in even.
Is that right?
Yeah, and that's another binder and strengthener. Earth plasters can be extremely durable. There are samples of earth plasters 700 years old, still intact. And so we're relearning all of the information that's been lost. When cement came in, a lot of the knowledge was lost, and so we're starting to put it back together and figure out what makes a good hard mix.
I'm sure everyone must want to know, why don't you just use cement? I mean, why are you choosing to go with the natural materials?
Well, on straw bales, cement doesn't breathe, and as well as earth plasters does, or lime plasters do. And in order to prevent moisture buildup in the bales, we want walls that breathe. It's also tremendously gorgeous. I mean, there's no finish that I've found that is as beautiful as an earth plaster.
Is that right? You wouldn't think of that looking at a pile of dirt, that you could get a great finish from it. In fact, you've already started working inside with different experimental recipes here, seeing which one works best for you?
Yeah, we have. Would you like to come see them?
Sure, let's grab our stuff and go in and give it a shot.
Okay.
Now, where we are is in the room that they call the meditation room in this house. As you can tell, it's a round room. We've got some skylights overhead, and it's got a very interesting feel in here. And Keely, this is where we're going to do our test batch?
That's right.
All right. You've got other areas in the house that you've got other test batches on. So I mean, how do you put this stuff on?
Well, it's a little tricky because it's quite thin, but basically, we're just going to slap it right on like that.
Really?
Yeah. And the idea is to work it as far back into the bale as you can so that, you know, we kind of get a good bond with what's there.
Can I give it a shot here?
Please do.
All right. Oh yeah, it is. And yet, just
Great.
mush it in.
Perfect.
Wow. It's an interesting feel.
Yeah.
I'll give you that.
Mud is a lot of fun to play with on the walls.
Now, is this how you're gonna do? It's take forever to do a wall this way.
Right. We're going to be spraying this on. The first couple of coats we'll spray on the walls. Since this is just a test batch, that's why we're putting it on my hand.
All right. Now, Keely, you're going to let this sit up and dry for a couple of days?
And then we'll come back and see what makes the best mix. What's crumbly, what's dusty, what's not.
And compare it to all your other test batches. And then later in the show, Robin is going to get to work with you, Keely, and we'll see an actual wall get done. Well, now we're ready to get started actually laying these bales in place here. And Aram, we've started by preparing the foundation. Tell us what purpose the gravel serves here.
The gravel lifts up the bales from a flat surface, and that allows ventilation to happen underneath to dry out the condensation.
You don't want the bales sitting in any kind of dampness at all.
Yes, if there's air, it keeps dry.
All right. Well, are we ready to start putting them on here?
Yeah, we can take one of these.
All right.
And let me pass over to this side and check the bottom.
We get them started
Right
in the rebar.
hole, yes.
Got it. Okay. This fits.
Fits.
You ready? Sit this down. Now, this PVC pipe that you have in here, Aram, that's to contain the concrete pour, correct?
Yes, it spreads out the straw, and it allows us to do a continuous concrete.
You were telling me it's very important that the concrete not be contaminated with straw in the middle of it, because that would weaken the column.
Yes, so at each course we're trying to have a free concrete connection. Each bale you put in is about 9 adobes, 4.6 concrete blocks. So every bale we place, we are ahead
We're doing a lot of work.
in square footage.
Very little time here. That's great.
Yes. Yes, they put some caps, as you can see. The reason of the caps is that when they are putting the second bale, it doesn't, let's show one, it doesn't let the straw go inside.
Right. Again, trying to keep from contaminating your column of concrete.
Yes.
So we're ready to actually pour some concrete?
Yes, and here's Philip going to pour some.
All right. I'll stand back a little. Now, I noticed you give it a nice wet mix for your concrete.
The reason for that is straw is like a wick. It sucks all the water very quickly. So we put some extra water to compensate for that dryness that happens quickly.
Right, because you don't want concrete ever to set too quickly, because again, that would weaken it, right?
Yes, the water amount is very important. The water makes it set, come to a strength.
Makes kind of a cool sound too, Aaron.
Yes. Then you start turning it and pulling your form out.
Okay, so at this point we're actually ready to remove these. That's interesting.
Yes.
Okay.
You see, what happens is the concrete settles down, as you can see.
Yes, like looking in the hole there, you can see it.
Yes, and what we will do next is Philip is going to bring some more cement, a concrete mix,
Yeah.
and we'll top off the columns.
So now this step, you do this every second course as you go up the wall of the building,
Yes.
correct?
So we get the rebars and place them in the middle of the column, and then we shake it a bit.
Now, you're doing that because we've got rebar coming up from the foundation, which is poured into the foundation, but you want to lock these two together, right?
Yes, because these have friction ribs on it. You don't need to tie them. Concrete ties them together.
Right. The next couple of steps here give us lateral strength. Am I using the word correctly?
Yes,
lateral
it
strength.
creates a rib at every second course, about 2 inches thick, with a diamond lath
Right.
and a horizontal rebar that would create a lateral strength ribbing.
So the lat's going to go down first here.
We cut a little slit in the lath, and that helps us to pass the rebar through.
Okay, Arjan, if you give me those snips, I'll do this one up here. Make a cut out so we can jam the rebar down through it.
There you go.
Okay.
And there we have our lateral stiffening rib.
Alrighty.
Underneath, we'll straighten it out a bit. And then
So
Philip is bringing more cement.
we sit this
Before-
diamond lath down into the bed of mortar.
Yes, and before the next course of cement, we take a number 4 rebar and we generally weave it
Oh, look at that.
between each rebar. And then we put some more cement on it. I'll generally get the trowel maybe.
It's interesting to see all the steps here, more than I thought. Look, when we first heard that you were building houses out of straw out here, well, I thought you were pretty crazy, you know? I mean, how strong could a straw house be? But you've come up with a pretty nifty system here, Aaron. This has got a lot of strength to it.
Thank you. Thank you.
There are some precautions you need to take when you're building with straw bale. Since we're out in the high desert, there are lots of mice around. This gadget will emit a high-frequency sound that the mice don't like, so they'll stay away. Our troubleshooter, Tony Buck, has some other precautions we need to take when you're building with straw bale.
I'm inside the foundation of what will become the master bedroom and bathroom suite. Now, solar power is a much more subtle system than when you're on the main power grid and you can run a big furnace or an HVAC air conditioning system. So every little bit that you create in energy you want to save. So the foundation is quite crucial. And this is a poured concrete foundation. It goes about 3 feet into the ground to get below the frost level. But the difference here is they've put 2-inch styrofoam panels down into the ground, all the way down on the outside and on the inside. And that's because any coolness or heating you create on this floor or in this air, you don't want it transferring back through the foundation wall into the outside world, because this is a really good idea when you have low energy sources, and that's going to make sure that we maintain the condition we want inside of our house.
Now we're ready to install our windows and our window sills. Now this is another element that will make the whole solar energy process work here. Again, I'm here with Aram. Tell me a little bit about this stone that's going to be our windowsill.
Yes, this stone is from Arizona. It's called a Arizona rose sandstone. It is 2 inches thick and it's 24 inches wide.
Now it's really wide because our straw bale is about 18 inches wide, and then we have to account for the stucco on either side, the interior and exterior.
Yes, and it leaves us overhang space in both sides.
Right, so that's why it's so wide.
Yes.
Okay, and you want to make a cut here. It's already been snap cut, but you want it another cut. Why is that?
These are snap cut at the quarry, and that leaves us some irregularities. So now we're going to take those irregularities in both stones, because the opening is wider than the stone we have. So we will use 2 pieces of stone to be able to span the opening.
We're starting to put our concrete down on the sill here, and let me explain the rough-in here. We have our straw bale, we have our rebar that goes at a horizontal, but we also have rebar that comes up at a vertical, and they've been tied together. In fact, there are a couple places where they meet here along the sill. Now we're putting our concrete down for a mortar bed. It's going to be about 2 inches thick, and it's going to be all along this area. Now we cut our stone first so that we had some time to work with the stone and make sure that it was at a nice slant. We want to add a slant and not completely flush, because we want to have a drip edge, maybe a 2-inch drip edge, so that when the water comes down, it just drops off and away from the house. So we're going to make about a 2.5-inch bed here, and we'll put that down. Now the nice side is facing us.
And then you grab this end, please. Okay, now down. For the second stone, we spread out the cement, clean it a bit, and feather it this way. So once we are vibrating the stone to set it and level it, this extra cement doesn't fill in between the rock.
Just like happened on the other end.
Yes,
Okay,
exactly.
so we're ready for another piece, and we'll get that into place, and when we start to shake it down into place, this mortar will come up and be in between this joint right here.
We're wanting it not to come any higher than the lower edge of the stone.
Okay, so let's get another piece. Okay.
Now we have to go parallel. How are we there, guys?
Good.
Pretty good. The front needs to come to me.
You'll notice right here that this is real snug, and everything is going to be that way with this installation of the window. In fact, there's only going to be a 1/4 inch reveal all around the edges, so we really have to be right on the money.
Okay. Right there. Now, if you lift it up a little bit, they'll hold it right there.
Right enough.
Let's see if it fits first with the swing clearance. Fine, we have way more than what we need up there.
Now we're ready for the self-expanding polystyrene, and we're going to put that right around the edges here.
And the important thing about the polystyrene is it expands 3 times its bead that you apply. So we try to be very quick with the bead and limit the size of it to about 1/2 inch.
This house has been laid out and built so that one of the longest sides of the house faces the path of the sun, which goes across there. Now when that solar energy is banging in through here, it hits this wall and it goes in through these windows at either side of the entrance. Let me show you what that sun does once it gets inside. Well, you wouldn't expect to find a bridge inside of a house, because a bridge usually goes over water, and that's exactly what it's going to be doing here. This whole area is a pond. It's going to be filled up with water to about here, and that gives us what we call a thermal mass. And the sun's rays are going to be coming in through this window and the window on the other side here, and hitting this thermal mass, or this water, and heating it up. And then this heat is going to radiate off and heat this part of the house. Let me show you another example of passive solar energy in the other room. Now it might look as if someone has just dropped a big pile of stone in this area, but this stone, to the solar energy engineer, is called thermal mass. It's going to absorb lots of heat. We're going to get an adobe floor in here. It'll be beautifully leveled, and that will be the finished floor. And over here, through the window, we'll beat the sun down onto this floor, heating up all these rocks. And also we have another example of thermal mass right here, this bench. And then once the sun's gone down, this heat's just going to radiate up off of here and heat this entire area. And with 300 days of sunshine a year in the Santa Fe area, our homeowners are going to be able to rely exclusively on solar energy to heat their house.
I'm here in what is going to be the pond, and I'm here with Keely Megan, and she's the plasterer on the job. And what we're getting ready to do here is put on our slip coat over the straw bale. And we have our mix here. Tell me about it.
This mix is actually just clay. We weren't able to use the site soil. It was a little too silty and not a strong enough mix. So we brought in another clay, and this is actually a good strong clay, so we don't need the manure, we don't need the glue or anything like that. And what we're doing is just taking our hands and working in a circular motion, and that kind of pushes the clay back into the straw and creates an excellent strong bond with this wall.
So this coat is for adhesion to the straw bale.
Exactly. We want it to make it nice and tight and just really gripping that wall.
This coat has nothing to do with shaping the wall or anything like that, does it?
That's right. The next coat will be a scratch coat, and it will have a little more sand in it, and it'll be more of a discovery coat, kind of to show us what the form of the wall is as it kind of stands. It'll be very thin. Then we'll go to an infill coat or a brown coat, and that's where we'll really shape the wall. We'll come up with the final form. And so the curves will look nice, the flat areas will look nice. If we want any undulations, those will be beautifully done. And then the finish coat will be very thin, and it will be the final texture and final color.
It almost sounds like the layers of a stucco wall.
Exactly. It's a very similar process, except that I do most of my shaping with a brown coat. That's really the big difference for me.
And Keely, there's no need for tools, no trowels, no anything, just your hands.
Right.
You really get right in there.
Right in. I love this coat for that reason. You know, you've got the beautiful clay and just put it on the walls with your hands. In later coats, we will be using trowels, but this is all we need for right now.
Now, how long would it take to do this whole room?
Well, it will take a couple of months to finish the actual entire plaster work. This room, if we had a 4-person crew working on it, would take maybe a day. Yeah, but we'll also be blowing this on with a machine at a later point. We'll have a stucco pump and just spray down the wall, and somebody will come along and do the circular motion with the hands behind it. So the earth will be going on the wall very quickly.
Now, how long does this take to cure?
Oh, that always depends on the weather. Right now it's pretty cloudy, and it could take 3 or 4 days.
Well, this is certainly a different house, huh, Robin?
I don't think I've ever seen a house like this before.
Well, you know, you're sitting on one of the big differences right there, all that straw. We built a house of straw out here, and it was very interesting to see Aram's own system that he developed with the reinforcing concrete to make a super strong structure, but yet it's still made out of straw. Pretty impressive.
And using the mud plaster was also interesting. It's a process that's many, many years old, and we're reusing it here in the house, using materials that are found in the land right around the house and putting them on the walls. It's environmentally friendly as well. It's a terrific process.
Well, there were a lot of environmental aspects to our project here. Where are we? We're out in the high desert. We get 300 days of sunshine a year. Sun is probably their most abundant resource. So this house is not even hooked up to the power company, and yet they can get all the electricity they need from the solar collectors. Another great aspect to this house. Well, we're all out of time here. We're wrapping up at this house and off to find our next interesting project for you. We hope you join us right here on Gimme Shelter.
We'll see you then. Bye-bye.